Hello community! Today we have two beautiful new AI systems, Genie 2 and PaliGemma2. So let's start with Genie 2, the brand new prompt-to-game system. Now, you remember 9 months ago I did this video here on game AI development and showed you here Genie and the inner workings, and we had a look here at the publication by Google DeepMind here February 2024, and we were talking about here how is it possible that we can generate here a video game. Now, you remember 2022 high-resolution image synthesis with Latent diffusion model. This is here if you really want to have a deep dive in our diffusion world models. But of course, you can also have here, look at my videos. Genie 2 is of course an autoregressive Latent diffusion model trained on a huge video dataset that Google accumulated over the years and used now as a training dataset. So after passing here through an autoencoder, our latent frames from the video are passed to a large transformer dynamics model trained with a causal mask similar to that what we know by our LLM models. If you want to see this here, you have a text to image model here. Google uses here its own vision language model here to generate this image given your textual input. And then we have here the world diffusion model where you say, okay, now I want to steer the action given now a 3D game world is developed. And if I press now a merge button or forward or go left or attack now, then the figure here, it learned really from the video game dataset exactly what to do in this new environment. Now, if you are not sure about the theoretical background on how to code this, I have a complete video playlist on my YouTube account here, 22 videos here. You see everything from stable diffusion, if you want to code this here in JAX with multi-parallel TPU, or if you want to understand vector quantized variational autoencoder here for general image generation, or you're gonna go here for UNAT and clip and whatever. I even have here the latest video here. If you want to go really advanced and you use here from theoretical physics here, the spin class model for the diffusion model, a new mathematical model here for an improved performance, but you don't need this. What you need to understand that our autoregressive latent diffusion model is simply here a combination of the autoregressive model that we know, that we love, and our latent diffusion process. And it generates, combining these two, a coherent sequence of data such as images or video frames. And this is exactly what we need to build our video engines. So, especially particularly effective here in scenarios where we maintain the temporal and the contextual consistency if our agent is running around in this virtual 3D world. So, generated data points should be coherent with the past frames. Now, how we do this from an architectural AI system point of view, it is what you already know from Genie. So we have a latent space representation. Data is first encoded in a lower dimensional latent space using techniques like variational autoencoders. See, for example, my videos. So this compression captures here the essential features. If our agent is running here, for example, in the savannah, you don't need to have here a calculation here of every pixel that is available on your monitor. You just capture here the essential features while reducing here the computational complexity for your AI model. Second, the diffusion process itself in the latent space here, operates here within the latent space, learning to reverse here the noising and denoising process applied to the latent representation. UNAT here, this involves training the model to denoise the latent variables, efficiently modeling the data distribution in a compressed domain. Further details in all of my videos. And then we have the autoregressive conditioning, where we have now that the model incorporates the autoregressive mechanisms by conditioning the generation of each single data point on previously generated data points. If you want to go further, I would recommend this paper here from the end of October 2024, a further methodology to stabilize here the latent space for image autoregressive model here. They try to come up here with a unified perspective. So they have here the relationship between the latent space and the generative models here, emphasizing here the stability of the latent space in image generative modeling. interesting approach, but only if you want to go further. And on GitHub, you have already the code available for you to play around with it and get a feeling if it's really better. However, on October 11, 2024, we also had here our agents. Now, in Google DeepMind world here, it's called here SIMA, so scaling instructable agents across many simulated video game worlds. So if you want to get familiar here with instructable agents, if you have a person running around, for example, in your video game, this is exactly what we are talking about. They can accomplish anything a human can do in any simulated 3D environment. And yes, it's not only for for pure consumer games. You can imagine, if you have a simulated 3D environment, what you can do also in non-civilian applications. So Google tells us our SIMA agents here interact with the environments in real time using here genetic human-like interface. I mean, real time means for the compute infrastructure by Google. I don't know if it's 100 GPUs or 1,000 GPUs, but real time, if you have here virtual video environment generation, real time is a little bit different what you and I might understand under real time. So let's talk about Genie 2 here, this large-scale foundation world model, which is absolutely beautiful. So what we're gonna do, we're gonna have a look here at rapid prototyping, and let's see what's happening here. So we start here with an image, text to image generated, and this image serves now here as our blueprint to generate virtual three-dimensional worlds. We can move in, we can play, we have actions, and we can control it with a mouse or maybe with voice. You see here, this is the power of Genie 2. Or if you have here an African landscape here with these futuristic elements here, this is here an image you generate here with a single image here, a three-dimensional world, and this is what Genie 2 does after being trained on video sequences, I think, from all over the world. You have AI agents acting now inside of the world model. We have what I talked about here, the SIMA agent that was developed here by Google. So you start here with an image generated here by a text-to-image generator. You take whatever you like, and then you just say open the blue door, and you see the house is generated now with a blue door, or you say open the red door, and the house is generated with a red door. Or if you have two houses, you know exactly where your agent will move to. Also here, turns around, so you can have voice commands or cursor commands or mouse commands or whatever, or go behind the house, and AI generates the game environment. Now, this is really a step forward. You have this particular image, go up the stairs, and the system knows this because it has been trained on millions of hours of video sequences. It knows exactly what it means to go up a stair and how to create here this virtual world. Or go where the plants are. So there will be a room, or as you see here, a doorway, where you can go now into the world here where plants are. And go to the middle door. So it has here the perfect understanding, the semantic understanding here of our text to video images, and it generates this world based on its training data set that has been pre-trained on. So coming back here, now you would say, but now we have to talk about the new OpenAI O1 Pro model. No, I don't think so, because in my latest community posting here, I had my thoughts on this model, that you now have to pay $200 a month to have access to this model that has just an improved test time, training and compute functionality. So let's talk about PaliGemma2. And I think this is a real interesting, beautiful new AI model, also by Google. Now, yesterday the paper was published, PaliGemma2, vision language model here, especially for transfer. And I have to tell you, this is a very special AI model with a very specific orientation towards, let's call it, scientific application. You might say, why? Now, at first, of course, PaliGemma2 is an improvement, but also a continuation of PaliGemma. I have several videos on this. We have a vision encoder and a language model, and now with the new Gamma 2 LLM from Google. Of course, you can imagine we have also an update now to PaliGemma2. We have 3 sizes, 3 billion free trainable parameter, 10 and 27B. The interesting thing now is they are building now a real powerful pre-trained vision language model for you to further fine-tune it on your specific application. So this multi-stage pre-training is here the most impressive thing you should remember. We have 3 stages as in Pali 3. So first here, stage 1, here's a joint training of the vision encoder and the language model and multimodal task at 224 times 224 pixels, focusing here on the transferability. Stage 2 is here progressively increase the solution to 448 and then almost 900 pixels, targeting tasks like OCR and detailed spatial reasoning. And then we have a task-specific fine-tuning for benchmark a new application, for example, molecular structure prediction. And now you see, now we're coming here, why this model is so important for science. Google here tried here to optimize the model here for the further fine-tuning for molecular recognition or medical imaging. So these are now highly orientated vision language model. If you are for radiography or you have whatever, PET scan or whatever. So to improve here the resolution here and the size that the model can handle, they are here that you take this model, this pre-trained model, and you fine-tune it on the X-ray images of your particular machine, of your PET scanner, of your data that you have available in your hospital or wherever you are in a research laboratory or at a clinic or at a university. Great. Yeah, very nice. Have a look at this technical documentation. You have image input, text input, and Gemma 2 is just a continuation of Gemma. You find here, as give you here the link, all the information, of course, Google AI for developers. You have PaliGemma. If you want to see here what is special here of the version 2, the model card, you have here all the information. And if you want to have a detailed information on the pre-training dataset, and this is now interesting because you want to know if you want to optimize your fine-tuning process, you have to know on what particular data, on what particular task, and what particular dataset PaliGemma has been pre-trained on. Because you can't just do here a domain shift to a new domain. This fine-tuning will not have the performance that we thought we could achieve. We learned this in a better way. So we have to know here exactly here the pre-training data set. Google here opens up here and it tells us exactly what it was pre-trained. So we have now a good idea on the pre-training data complexity and the data. You find all of this here, of course, here Google Gemini Gamma Cookbook. And then you see just 14 hours ago, you have now available also for you in Apache 2 license open source PaliGemma2 to update here for the new notebooks. Talking about the new notebooks, of course, we are here with Google. So remember, we are doing here with tensor processing units here, so for TPUs. And of course, we have the real parallelization optimization with JAX. I think I have multiple videos on the JAX implementation if you want to have a look at this. But you have here the complete Python notebook. You also click here and you run it in a Column notebook. You have the complete source available. You have also the detailed instruction how to fine-tune this model. All the detail, everything is available for you. If you are not familiar with JAX, no problem at all. They also have here a particular notebook how to fine-tune PaliGemma2 with the Keras implementation, Keras 3, beautiful. So whatever you are familiar with, Keras is available for you. This is great. Of course, you have those models, as you can see, just 19 hours ago, 18 hours ago, updated also on Hugging Face. They say, hello, PaliGemma2, a new vision language model by Google, published today, December 5th, 2024. But remember, this is really for further fine-tuning. This is not a model that you can use out of the box. It will not have the performance. This has a so specific pre-training procedure for hospitals, for molecular imaging, or for scientific application, let's call it in this way. So you cannot use this just as a pure model that already has been fine-tuned and reinforcement learning and everything. This is what you have to add to this system. But you have an excellent pre-trained model, and you see we are going back now in the complexity, and we are just providing some very good pre-trained model, and then it is up here to the client, to the customer, to the hospital, to the university, to the company to further build on this. And we have no problems here with already happened catastrophic forgetting if somebody else did a fine-tuning and now we don't have access to the pure crystal powerful pre-trained model. So a beautiful development. Yes, we need those pure and powerful pre-trained model. Also, I think you got the idea. Of course, we have also in Hugging Face already fine-tuned model for very specific data sets. So you see here PaliGemma2, the 10 billion free trainable parameter, now fine-tuned on a dataset. And this dataset you have here, the link, and also here the paper by Google and Princeton University, the description of connected and contrasting images. So these are a really selected dataset for the pre-training. So finally, we are coming clear of this. Oh yeah, the model has already pre-trained and fine-tuned and then DPO trained. And then, yeah, we had some instruction tuning. And then, no, we don't need this. This is not going to work. Because the pre-trained data set and the fine-tuned data set, if they are not coherent in their complexity, in their structure, you will override the goodies from the pre-trained phase. Great. Yeah, let's have a look at the demonstration, and I'll show you 2 additional code notebooks for you. If you don't want to go here with Jax or Keras, of course, Hugging Face provided here a solution, as also they provided here a demonstration. So Hugging Face here, take now the task, it fine-tuned here the PaliGemma, the small 3 billion free tradable parameter with the lowest resolution, with 448 times 448 pixel resolution here on a small portion, unfortunately only here, of the visual question and answer version 2 data set. They used here the LoRa fine-tuning here as a parameter-efficient fine-tuning methodology, and I will give you here also the link to the specific Colab notebooks. But let's examine where it fails and where it succeeds, and you get a feeling if you use this here on a 3B model, which is maybe not the best idea for a medical application or pharmacological application or molecular chemistry application. Let's have a look about the performance. But of course, we want to see this here in real time. So we go here to our spaces here. Thank you, Murph, for PaliGemma2. Beautiful. So let's see this experimental research model. So I uploaded a real complex image dataset. So here an image, and I say, give me a short summary of the technical content of this image, because I want to make sure here in real benchmark, hey, is it able to read this? Is it really able to get an idea what this is all about? And it is a technical content. So I just don't want to go here with read an email. Yes, of course it can read an email. Max new token set to long, let's say 110 tokens, and submit this. And you are now live with me here. Is it able to do this text output? We are waiting. As you can see, this here is from here an AI agent model for equity research that I showed you here in my YouTube channel. If you want to have here for financial AI agent for equity research and valuations here of stock and whatever here with LLM agents, this is here exactly the paper here for the financial multi-agent chain of thought configuration. Text output none. Okay, I would say this is too complicated. No problem at all. No. So let's go here. What is the password? Okay, let's check this one. What is the password? And we go for, I don't know, 30. Submit. Let's see if there's the password. You see here AAEU. So we are waiting for the result from an image. AAEU. So, okay, this is the level that we are doing, because remember, this here is the model that was trained here by Hugging Face itself. And of course, it was trained here on a low resolution image. And of course, what I uploaded was a little bit out of scope. So let's do another example here from OpenAI. You know, the new Pro plan where you have to pay $200 per month to get here the new O1 Pro version. How much does the expensive Pro plan cost now? Let's say submit. Let's see if it gets it right. I think it should be able to read here everything. This is here live. You see it here live. So text output is, we're waiting for the result. $200. Yes, it got it right. So you see, these are now here for PaliGemma2, the improved PaliGemma model here. What it can do, so please remember, this is definitely a model you have now to fine-tune to your particular dataset. I hope I've given you here a very short overview. And as you can see from Hugging Face itself on Small Vision GitHub, you have here now an update here from PaliGemma Pi. So you have it here just 13 hours ago, a brand new notebook. And here we have everything now. And we have now the new model optimized here, PaliGemma2, the 3 billion. Okay, so here you have your complete code. If you want to go here with LoRa, you want to use here bits and bytes configuration here for the quantization. This is the code for you. You have your training arguments, whatever you have available on your compute infrastructure. Then you have the trainer and you simply say trainer.train. So this is the code. Great. So nothing is holding you back to train you now the new PaliGemma2 on your specific dataset. And yes, of course, there is also a column notebook here for PaliGemma2 fine-tuning. Exactly here, beautiful. You install bits and bytes and everything, and then you just load the dataset here from our beautiful Hugging Face, and you have here the new model from Transformer, import PaliGemma processor, model ID from Google PaliGemma2, and then you have here your code also available here in the column notebook. But please remember, you have to connect at least to a A100 because this is some quite intensive data, depending also on your image training dataset. So there you have it. Code is available for you, a Python or a Python notebook, whatever you like. The code is there. It is waiting for you to optimize here PaliGemma2 to your specific needs.